Hello Algebra 2 students, this is Mr. Chun, and we're going to be talking today about the properties of logarithms. Here are the lesson objectives. We want to be able to simplify and evaluate expressions using properties of logs. So we'll talk about what these are. And then we're going to solve equations. So remember, simplify and evaluate means something different from solve. And so we'll look at what those mean. Here are the properties of logs. This is just a review. If you've done your investigation, you should have seen some of these. Let's start from the top. These three we've already talked about. We said this is a special example. The log of any base to the power of 1, or to the log of 1, no matter the base, is always 0. And that's because a to the power of 0 is 1. Anything to the power of 0 is 1. The log of a, base a, is always going to be 1. So remember, this cancels out to 1 because a to the power of 1 is a. Remember that these can be rewritten. And log of a, log base a of x is equal to the log base a of y. If that statement is true, then x equals y. So the arguments can be set equal to each other. Also from the investigation, you should have seen that this property is true. The log base a of a product is equal to the log base a of the factors, or the sum of the logs of the factors. Okay, so if I have u times v inside, I can split these up, and then I can add the logs of those factors. And that's called the product property. The quotient property is very similar to the product property, except when I have u divided by v in the argument, we take the difference of the log of the numerator and the log of the denominator. Okay, and then the power property says if I have u to the n, if the argument is raised to the nth power, I can bring that n to the front and multiply it by the log of u to the power of 1. Okay, so these are all the properties of logs. You should know these, be very familiar with these. Especially these you'll have to memorize. These will be given to you on the test, but you should still know them. Okay, so let's apply the product property. Because we know that if the argument can be divided into two factors, we can add the logs of those factors and still have the same expression. We can change these following expressions into a sum of logs. So log base a of mn would be the same as likewise at can be split up into log of a plus log of t. Log of the word math, if these were all individual variables, could be split up into the sum of 4 logs, where each of those logs, those arguments, are individual letters. Okay, so let's try and go backwards now. Express as a single log, log of 19 plus log of 3. Obviously this is all in base 5. We could express this in base 5, log base 5 of 19 times 3. And so 19 times 3 is 57, and so the log base 5 of 57 is the same as this statement, or this expression. Okay, log of c plus log of a plus log of b plus log of I plus log of n is going to be equal to log cabin. All right, that was a bad joke, but there you go. This is the product property in use. This one says express as a log of sums, then simplify. So let's take it one step further and simplify once we've separated this expression into a log of sums, or a sum of logs. You can see that there's going to be some connection here between 4, 16, and 2. Okay, so we're going to somehow use these and simplify. So first we split them up like this. Then what we can do is, once you see this 4 and 2 are related, 16 and 2 are related, right? 4 is 2 squared, 16 is 2 to the power of 4. So we can rewrite those like this. And I think you can guess what's going to happen. This 2 and this 4 can be, these numbers can be brought to the front using the power property. And so you end up with just 2 plus 4, and of course you get 6. So this would be one type of simplification problem that you might encounter in the homework. Set it up into a sum of logs, okay, of the factors. So it's going to be log base 5 of 3 plus log base 5 of 7. And then, of course, we can just substitute this expression with 0.683, log of 7 with 1.209. Then you just add those, you get 1.892. So this is one way you can approximate, given these numbers, okay? You can approximate certain expressions without the use of a calculator. Quotient property, again, this is going to be the same thing. It's just a different formula. Okay, so here's an example. It says express this expression as a difference of logs. We can take the numerator and the denominator. We can split this up like that. And we can say the log base a of 1 minus log base a of 4 is the same as log base a of 1/4. Okay? So you can see here we've taken the log of the numerator minus the log of the denominator. Okay, so here's another example. We're going to do the same thing. We're just going to substitute this expression and break it up into the difference of logs using these two expressions, and then substitute every time we see a log 3 with this, and every time we see a log 7 with this, and try and simplify. So we end up with that, where we have the log of 3 minus log of 7, and then from there we can substitute 0.683 minus 1.201, up with a negative number, negative 0.526. Okay, so this is an approximation of this using these values. Okay, let's talk about the power property. And let's look at some examples of this. Okay, the power property says if I have the argument raised to the nth power, I can bring that exponent to the front, and I will still have and multiply that to the log of u to the power of 1, and that is equal to the same thing. So here's an example. Again, we're going to take set 3 and 7 and maybe somehow manipulate these to create an expression for log of 49. Well, let's see. We don't even really need this one, this expression here. We can simply change 49 to 7 squared, and now using the power property we can bring the 2 to the front. And then we can multiply these two together, 2.418. Okay, so here's another example. It says solve each equation. For part A, we have 3 log base 5 of x minus log base 5 of 4 equal to log base 5 of 16. All right, so everything is in log base 5, so that's nice. Can we express this side? This side looks pretty complicated. Can we express this so it's a single log? So we have log base 5 of something. If we can, then we can set the arguments equal to each other, right? So let's try that. So we end up with log base 5 of x cubed, and that's using the power property, minus log base 5 of 4 equals log base 5 of 16. Okay? And now we have a difference of logs, so let's try and simplify this. This time we're going to consider that whole thing as the numerator. So we can say log base 5 of x cubed over 4 equals log base 5 of 16. Okay, and now we can set the arguments equal to each other because our outsides are the same, right? So we can say x cubed over 4 equals 16. So x cubed equals 64 if we multiply both sides by 4. And then if we take the cube root, well, 64 is the same as 4 times 4 times 4, right? So if I take the cube root of that, well, then I just get x equals 4. Okay, so that would be the solution to this statement. If I plugged 4 back into there, that is what I would get. Okay, let's try another one. Log base 4 of x plus log base 4 of x minus 6 equals to 2. So let's try and simplify this. We can simplify one side, or the left side. Let's make that a nice simpler equation and see if we can do something from there. Okay, we can go log. This is a sum, so we can multiply. We can go log base 4 of x times x minus 6, right? We can take this and multiply it with this, and that's equal to 2. And so we end up with x squared minus 6x. Okay, that would be on the inside. We have log base 4 equal to 2. Okay, now we want to try and rewrite this so that the log isn't there anymore. We want to solve for the argument. So we're going to say x squared minus 6x equals 4 to the power of 2. And then we can, now it's just a quadratic. So we end up with x squared minus 6x. And that's 16. We bring it over to the other side, so we end up with minus 16 equal to 0. Okay, so we can now factor this side. It looks like 8 and 2 will be my factors. Okay, and this is negative, so, and the 6 is negative, so it's going to be this. Oops. And then x equals 8, or x equals minus 2 will make this statement true. Okay, but we need to go back and check, make sure that the original statement is true. If x is negative 2, that will make this log undefined, so that won't work. So my answer is going to be x equals 8. That's the only one that will make this work. Okay? Okay, and this is something that you need to be careful of. It's easy to get confused with the different properties of logs, so just make sure that you recognize the log of x plus y. So if there's a sum in here, that's not the same as this. Okay, so I can't, if I have the sum or a difference, I cannot rewrite it in this form. A lot of students make this error, so please be careful not to make this error, and you'll be okay. Okay, these are some practice problems. You go ahead and try these, and we'll talk about the answers in class. All right, these are the homework problems. Thanks for listening, and have a good day. Bye.